What do you think of when you hear the word sharks? Does your heart beat a little faster? Does thinking of sharks make you a little nervous to go swimming in the ocean? Well, if it does, you're certainly not alone. Many people think sharks are aggressive, terrifying beasts that stalk the oceans. But are they really menacing hunters that attack humans at will? Or are they one of nature's misunderstood predators that has an important role in the balance of biodiversity on the planet? It'll be easier to decide if sharks are friends or foes after you look at life from the shark's perspective in this edition of Saving a Species, Sharks at Risk. Hi, I'm Sarah Paxton. On my show, Darcy's Wildlife, I've encountered many different types of animals, but never one quite as intimidating as the shark. That's probably part of the reason they get such a bad rap from humans. But there's a lot more to sharks than meets the eye. Sharks are fascinating creatures, and they come in all shapes and sizes. Some sharks are sleek and angular like the bull or lemon shark. Nurse sharks have larger heads and bigger profiles, and some, like this hammerhead, are just plain bizarre looking. These efficient swimming machines range in size from the bigger than a school bus whale shark, nearly 14 meters long, to the tiny pygmy ribbon-tailed cat shark, which only grows to about 25 centimeters. Some sharks are flesh-eating ocean predators, but other sharks eat nothing but plankton. Regardless of shape, size, or diet, sharks have interesting and unique characteristics and a specific role in their environment. Sharks can be pretty cool, and I bet you'll think so too, once you get to know more about them. Well, sharks are one of the oldest species on Earth, with scientists estimating that ancestors of today's sharks inhabited the oceans between 350 and 400 million years ago. That's millions of years before dinosaurs and other backbone animals roamed the Earth. The most spectacular ancient shark was probably the megalodon, a huge shark with teeth the size of a human hand. This one was probably a flesh eater, and at an estimated 40 to 55 feet long, that's 3 or 4 SUVs end to end. The megalodon was likely the top predator of its time. 100 million years ago, about the time dinosaurs were around, sharks looked pretty much like they do today. And unlike other animals, they really haven't changed much in the last million years or so. That's probably because they are highly suited to their environment. Sharks can actually be found just about everywhere in all types of waters, from shallow coastal habitats and tropical lagoons to deep water open oceans and polar seas. They can live in salt water, brackish water, and sometimes even in freshwater lakes and rivers. Sharks are fish, even though they don't look much like the ones we commonly think of. But like all fish, most sharks are cold-blooded or ectothermic, which means their body temperature is controlled by their environment. They also have a skeleton and fins, live in water, and breathe with gills. But that's where the similarities stop. 96% of the nearly 24,000 different species of fish that exist today are classified as bony fishes because their skeletons are made of bones, like ours. But the 350 or so species of sharks are in a much smaller class of fish called chondrichthyes, or cartilaginous fishes, because their skeletons are made of cartilage, not bone. Grab your nose or your earlobe, that's cartilage. Doesn't seem much like skeleton material, does it? I guess one thing we all realize is that most sharks have lots of teeth. But did you know some sharks will go through as many as 30,000 teeth in a lifetime? Sharks grow new teeth all the time and have several rows of teeth front to back. When they lose a tooth, one from the row behind just moves up to take its place. Sharks have very unusual scales that look like miniature teeth and are even made of the same things, enamel and dentine with a pulp cavity. And as the shark grows, it grows additional scales rather than the scales growing bigger like they do on bony fish. Believe it or not, people have actually used shark skin for sandpaper. Sharks are also famous for their sense of smell. The rest of the shark's senses are just as highly advanced. For example, their eyes are perfect for seeing in dim light and are particularly sensitive to moving objects. And even though sharks don't have an outer ear, their inner ear is so advanced it can detect sound, acceleration, and gravity. Plus, sharks have two other internal systems that help them find their prey. One is called the lateral line, which are fluid-filled canals in the shark's body that sense low-frequency vibrations. The other is called the ampullae of Lorenzini, and these are tiny sensory pores that run along a shark's head and can detect faint electrical signals generated by a prey animal. The only sense scientists don't know much about is the shark's sense of taste, but they do know what most sharks eat, and it's not what many people think. The truth about shark attacks, when Saving a Species returns. Sharks eat lots of things, but the big question often is, do sharks target humans as food? I caught up with animal expert Julie Scardina to set the record straight about shark attacks.
Sharks have a certain territory just like animals on land. And if you're in their territory, they're going to react defensively to it. They're going to want to protect their territory. If they perceive you as a threat, they're going to want to also protect themselves. Or there's a likelihood that the shark may think that you're prey, especially if you're in an area that other pinnipeds, seals, or sea lions are swimming in. But people don't realize that you're 30 times more likely to get struck by lightning than you are to be attacked by a shark. So there's a lot of different reasons why sharks may attack, but again, in actuality, the chances of being attacked by a shark are very, very small. You know, there's a lot of things we can actually do when we're out there swimming or thinking about going swimming. And first of all is to stay away from areas that have potential shark prey. Don't go swimming near seal or sea lion rookeries or large fish schools. If you see when you are in the water that the animals underneath are starting to act strangely, there's usually a reason. So you want to be aware of what's going on in your surroundings. And also, one very interesting thing is there's been a large recurrence of shark attacks in the same areas. So find out where those areas are and don't go swimming there.
I guess we do need to remember that we're swimming in their home. And if a shark is just out looking for lunch, how is it supposed to know we're not on the menu? Now that we know what sharks don't intend to lunch on, let's find out what they do eat. Different shark species eat different things, and while some are opportunistic and eat anything that comes along, others show definite preferences. Hammerheads eat mostly stingrays. Tiger sharks seem to prefer sea turtles, blue sharks eat squid, and whale sharks eat only plankton. Sharks also eat a lot less than most people think because they're cold-blooded and have much lower metabolisms, which means they need less food. It's likely that many sharks go weeks at a time without eating at all. So how do sharks hunt for their food? Well, their hunting strategies aren't that different from predators on land or in the air. Sharks, just like other predators, will attack the weakest and most vulnerable prey. And by doing this, they play a very important role in the balance of the ecosystem. This process of natural selection helps keep other ocean populations strong and healthy. Come face to face with sharks. Next, on Saving a Species, Sharks at Risk. Every conservationist's goal is to preserve and protect wildlife and wild places. That's why it's so important to learn everything we can. One of the best ways to reach that goal is research. Some shark research is conducted in the wild, But Mike Shaw, curator of fishes at SeaWorld San Diego, has worked with sharks for 28 years and has discovered an amazing amount of information.
Shark populations are under pressure in many areas of the world, and therefore the more that we can learn about sharks in aquaria, the more we can apply that knowledge to helping shark populations.
Managing the day-to-day health of the sharks is no small task.
We monitor these animals very closely. We look at them each morning and throughout the day to make sure that they don't have any injuries, that they're behaving normally, that they don't show any obvious signs of parasites. And when we do feed them, we put a number of vitamins and minerals into the food in order to make sure they're getting proper nutrition.
Exhibits like this have taught us a lot about shark conservation in the wild.
It surprised us to learn that they don't eat very much, not as much as you might suspect. We find that typically, depending upon the species, a shark would eat between 1 and 8% of its body weight per week.
We've learned a lot from basic research data, like growth rates and blood chemistry. But even more has been accomplished.
Perhaps the most important thing is we've had some reproductive successes here at SeaWorld. And these would include black-tip sharks, white-tip sharks, and bonnethead sharks. And what we've seen is that when they give birth to very small numbers, not huge numbers like bony fishes do, where they may give birth to hundreds or thousands or even millions of offspring. With many shark species, they're giving birth to 2 to 4 to 8 offspring at a time. This means that populations take a long time to build up because they're only giving birth to small numbers when they do so.
It's amazing how much we've been able to learn from sharks in the care of humans. And we've compiled a good database of shark information. But even with all this knowledge, there's still a lot we don't know. For one thing, many sharks have never been in a zoological or aquarium setting where they could be studied closely. So most of what we know about some species of sharks comes from studies in the field by dedicated scientists like Brent Stewart of Hub's SeaWorld Research Institute.
We're studying the whale shark, which is the largest fish in the world's oceans. We really don't know much about whale sharks. That's one of the great things about studying them, is everything you learn is brand new.
But finding whale sharks isn't always easy.
They occur in certain places around the world, like Ningaloo Reef in Western Australia, the Sea of Cortez off Thailand, at certain seasons, but between those times, we really don't know where they are. They just don't appear anyplace. We study them by trying to find out where they go when they aren't seen, and so we're using various kinds of tags to follow them through their lives.
In a study like this, specific information can be gathered.
The primary thing we're really trying to learn is where the sharks are. What are the habitats in the world's oceans that are important to the sharks and where they range? So that's geographical habitats, distribution, but also the vertical habitats. What areas in the water column do they use to make a living? And we thought that they were probably near-surface animals because they're filter feeders. But we've learned, in fact, that they're pretty deep animals sometimes. They go beyond 1,000 meters and they spend a lot of time there. So what we've learned has just created a lot more amazing questions about them.
All that's learned from this study can really benefit the whale shark.
Whale sharks are not often seen. They're seen in occasional these wonderful places like Ningaloo Reef, around Thailand, the Sea of Cortez, and in between we really don't know where they are. They are hunted in some places, and they're part of the shark fin market for soup. So there is some unregulated taking, and we're hoping that this will feed into that and try to help manage those areas that are either regulated taking, which is pretty limited now, or help increase some attention to those areas where there's unregulated killing.
Research is frequently a group project, with several organizations collaborating to provide better resources. That was the case for a nurse shark study in the dry Tortugas, when volunteers from SeaWorld joined the group. The project focuses on the reproductive physiology of nurse sharks, and collecting data is a #1 priority. Researchers from Albion University, the National Marine Fisheries Service, and SeaWorld Orlando meet yearly to capture, tag, and collect data on a number of nurse sharks. For Wes Pratt of the National Marine Fisheries Service, tagging is a staple of research.
We've been studying sharks at National Marine Fisheries Service for 35 years with a tagging program. That's natural extension of this is to study the nurse sharks now. We'll be putting a little hole in the shark's first dorsal fin and applying these blue tags with this little pair of pliers here. It's kind of like getting your ear pierced, and it provides a mark that lasts for as long as 27 years we've had this particular tag last on a shark.
Researchers collect the same information year after year as the sharks mature and add it to a growing database. With this collective data, the researchers are learning more about growth rates, reproductive physiology, and population stability in this particular group of nurse sharks. As head researcher Dr. Jeff Carrier of Albion University knows, it's important information to have.
Aside from the pure and applied science of the study, one of the things that's important is that sharks are commercially valuable. And if we're going to understand them and understand how many we can take in a commercial fishery, we need to know something about the rate at which they replace themselves. Part of the study depends on us being able to know who the animals are in the area, and for that we do a tagging program.
Nice job. Going right back to where we caught her.
Act fast. Sharks are at risk. Find out what you can do to help when Saving a Species returns. Now, I know it may be hard for you to be concerned that there are fewer sharks, but if we look at the big picture, every species is important to our planet. Anytime a species is removed from its place in the overall scheme, it adversely affects the whole system. Let's start by taking a closer look at how sharks populate. Shark eggs are all fertilized within the mother. But then there are three very different types of embryonic development with three very long names: oviparous, ovoviviparous, and viviparous. Oviparous means egg birth. In oviparous sharks, the embryos are protected by egg cases that the female deposits into the water and hatch later on their own. Ovoviviparous means egg live birth. With these species, a shell membrane encases the egg, or a group of eggs, inside the mother. At a certain point, the embryo sheds the membrane, completes development, and is born ready to swim. Viviparous means live birth. Viviparous shark embryos develop attached to the mother through a yolk sac placenta. They're born fully developed and ready to swim. Gestation varies among the different species and can range from a few months to as long as 2 years from conception to birth. Also, sharks mature and reproduce slower than other species and don't produce large numbers of offspring like bony fish. Add that to long gestation periods, and it's easy to see how shark populations are difficult to sustain if outside forces begin to adversely affect them, which they are. Already, the great white shark, the whale shark, and the basking shark are at risk of becoming extinct, and more than 75 species are considered vulnerable because their numbers are rapidly dwindling. Each year, humans cause the death of as many as 100 million sharks. It's the result of several factors: competition for the same resources, overfishing, accidental deaths, as bycatch in commercial fishing nets, and unnecessary killings due to superstition or lack of education. Whatever the case, we're killing sharks faster than they can reproduce. Also, sharks are very valuable to commercial fishermen because of an increased demand for shark products. One particularly wasteful type of shark fishing is called finning, where only the fins are cut off and the rest of the shark is simply tossed back into the ocean to die, all just to make fin soup, which some cultures view as a delicacy. So what can you do to help? Well, conservation begins with learning. So learning about sharks and why they are an important species to save is a good first step. You can also support legislation to protect sharks and their habitats, as well as legislation to make commercial fishing safer for all the bycatch species: sharks, dolphins, turtles, and others. You can do your part to keep the oceans and waterways clean for sharks and all other marine species, because habitat pollution is a major factor in wildlife survival. You can always support one of the many conservation organizations that are working to help the sharks. Organizations such as the Nature Conservancy and Wild Aid do research in several locations around the world to learn more about sharks. Another group is the SeaWorld and Busch Gardens Conservation Fund, which supports shark conservation programs to reduce overfishing and overconsumption of sharks and shark products, as well as many other species and habitat programs. So what do you say, friend or foe? I definitely say friend. I hope by now you think so too. Sharks are incredible creatures, and there's still so much that we don't know about them. Through continued research and education, we'll work to dispel the fears and myths about sharks. Because the only way to save an animal is to care about it and recognize its value on Earth.